Now we have more deeper concepts of multi-threading programming. And in this, we will dive into thread pool class and worker thread and few other important concepts of multi-threaded programming. So we have our uh, prompt ready and thread pooling implementation. That's what we're asking. Thread pool, create, and with some conditional variable, do the worker thread work mutually exclusive fashion, and the worker thread, and we have the main function should use the thread pool with, for example, 4 threads, and we want to see graceful shutdown, not exiting suddenly. Notify all threads and then exit gracefully. We want to have our statements, print statements with cout and cleanup of shutdown, thread assignment and execution. And our goal is to have a clear understanding by the beginners or advanced programmers about the task distribution, thread coordination, safe concurrent execution using a real world construct. Thread pool, it should be minimal, practical, and reusable. And let's ask our friend to generate code. Let's do that. There we go. It's working. Our friend is working, and it's exciting time that you can ask a computer to generate code, and you just have to think what we need. And even such a C++ code is complex. It can generate. The only thing is that we need to know what you're asking. ThreadPool class is created, and there are a lot of thread related variables, members. Worker thread is a function. It will generate worker thread. And thread pool destructor is shutdown, graceful shutdown that we asked. It will call shutdown method. And there is a submit method, and it's having a future, std future call. And there is a shutdown method. And we have create task. The main function is started. Thread pool object is created. There are 4 threads will be there. And okay, that's pretty much it. We have asked to create threads and thread pool. So what it did is core components, thread management, create and manage pool of worker threads, uses the thread safe queue and for pending tasks. Synchronization using mutex and condition variable. Those are the way synchronization is done between threads. For coordination, and task submission returns std future. Once we submit the task, we should have a future that is returned for getting result asynchronously. Exception handling is done, graceful shutdown is done, and we are using thread safety like mutex, condition variable, and atomic. And usage pattern is create thread pool with desired number of threads, submit the task, that return results and get results from the future we needed and let the pool shut down automatically in the destructor. And how it works, worker thread wait for the task in condition variable, process the task when notified, exit when stop flag is set, and queue is empty, queue for that thread. And task submission, create a packaged task that wraps the user function, gets future from the future, std future, from the package task, wraps the package task execution in a void function, and so on, and then synchronization. Queue access is protected by the mutex. All right, we'll go to the code and take the code to our editor as we did before. Oh, okay, here, up there, thread. We push that to the editor and it's here and apply to editor, and we call the file name ThreadPool, and it's a new, we are not updating the existing file, we are calling it threadpool.cpp, and threadpool.cpp, we have it here as the threadpool here. And we hide the chat window and bring it here. We see a compilation error detected by the ID itself. What do we have? Mutex. And let's fix it. This squiggly line under the text, it says that there is an error. Also, this file shows red. This is the fun part of the IDE. It's very helpful. What does it say? No instances of the constructor. And threadpool.cpp has this, protect access to the task. Let's fix it with Copilot itself, and let's see what it does. It's working to fix it. The error occurred because you're trying to lock the mutex in a const member function, which isn't allowed by default. And you need to declare the mutex as mutable to allow locking it in const method. So this is a const mutable. Okay, this method is made mutable, and we accept no, that variable is made mutable, and we accept it. And this was used here. This is the place it was talking, I think. Not this place, maybe was a line number. Here, there was some const function shut down, and somewhere, and the line number. So it fixed by just making it mutable, meaning it has to be able to change, protect access to the task queue. All right, let's go through the code and we'll execute that. First, let's try to compile here and thread pool and C++, thread pool, output, thread pool, without extension. It compiled okay. And we have thread pool. If we run, what happens? We'll see. Before that, we want to see the code. And let's go through that a little bit, and then we will execute the code. Where is our main? We'll start there. We have a vector of future instance and type int and results. So these results are here. So ThreadPool is a class and is taking a member, a constructor is taking a parameter of 4. That means 4 worker threads are created inside that class and submitting 10 tasks. So we are for those threads, we are submitting task and duration is this, some variable, and there is a pull submit create task. Create task is a function. Okay, and this is I is the index and duration is create the task with varying duration. Okay, so this is duration for the task. One will be a different as the values are different each time. And then store the future. That means the return of that pool submit to results. And then we'll see the class. And then that using that results, we are displaying something here. We'll come back. All tasks have completed. After that, what we see. So when threads are created, create task, and create task is here. This it's a function, and it has some lambda function returns with get thread ID a string, and it is creating the ID multiplied by 10. Return the result we will be captured in the future. Okay, so that's the task is created, thread thread str, thread ID is created. Thread str, what it does, thread str is just a function. It is getting a thread ID, printing thread ID. And now let's see the thread pool class. Thread pool has worker thread vector, workers, and then we have queued the function, queue the task to be executed, the task, and we have mutual exclusion variable, mutex, condition variable, atomic, we'll see how that is used, active task, that is atomic, and cout mutex. And this class has worker thread, and worker thread thread ID is created here, and that thread ID is printable. This we saw that above. It's a printable format, nothing else, just the formatting. And we have thread is created, and cout is locked, so that each thread can print their start statement. Then in the while loop, in the infinite while loop, we have the function, the task is a variable, and in the scope, we lock this, and on condition we wait until there is a task or a stop flag is set. So we'll wait till that point. This releases the log while waiting, other threads can access the queue. When notified, it reacquire the log before checking the condition. So it will wait there and then it will, okay, it will exit the pool. Pool is exit if pool is stopping and there are no more tasks. So it is checking if the flag is true, stop, and there is no more task pending for the thread, and then it will exit. Otherwise, it will take the task. This task will be sent by the another thread. This is a worker thread. And that task is taken, is moved from the front, and then we pop it, and then that task, to do that task, and we need to log the mutex so that we can print and execute the task outside the log. You make active task, how many active tasks at a time, and then you do the task. This is the method. And after that, try in the try block. If it fails, it will come to the catch and print it, see error. And that also within a lock. And after that active task, when it exits, it is saying active task minus minus. It is decrementing. Then the thread is exiting, shutting down gracefully. So we have a pool thread, that's a function worker thread. And we have 4 worker threads. We receive that number of threads. And if thread equals 0, set it to 4. And then the workers thread pool, this worker thread object, the function pointer is provided here to the workers. There's a function pointer, and then shutdown is called in the destructor. And inside that, there is a submit. I think we saw the submit here. The submit may be down there. So in submit is a function of template, as a template function where f is a template type name, and which is taking the f, and then it returns a future. This is a return notation, return a future with the and declare type, function type. Submit the task to be executed for the thread, and f is a task function, that's the function f, and then future that will hold the result of the function. So here. And then inside the function, we have std forward package task, and the task get the future. This is a method. And get the future result before we move the task. That's the result, and the task is a shared pointer, and then within the block we have unique lock for the mutex queue, and check if the pool is already stopping. The stop is a member variable, here, atomic. So will be always atomic. Then you have the wrap the package task into void function. When executed by the worker, this will call the package task. This is the notation. This is the function call. That's a function pointer. This is how we're calling it, which will eventually set the value in the future. Okay. And then we are printing using the outlook mutex so that nobody else can print, and task submitted queue size and task size. And condition variable, you notify one waiting thread that there is a new task. So this is submit a task. Whenever a task is added and we notify the threads, those are waiting. And shutdown is again with the lock and stop, signal all threads to stop. Stop is true, otherwise stop was false. And condition notify all. And then join all worker threads here, joinable. If the worker is joinable, then join here. And then it will join all worker threads, wait for them to finish. And then after that, once all threads are done, it will shut down. Queue size returns a queue size, active task count, that is the active task, static variable may be atomic. So, and we have thread count is a worker's size, return the number of worker thread in the pool, and create task, we saw that. And in that create task, we have the thread ID. And then where is the create task called here? Create task is a method, duration is sent, and is submitting into the pool, and pool, submit, the function that is coming here. And once it is submit a task to be executed by the thread pool. So that's what is happening here. And it returns a future and move that future to results and so on. So once that is created and the work with the sleep, okay, and submit, make shared. Worker thread, mutex, function, lock, wait. So this is a function here. So thread pool worker thread is a function pointer in that. And worker is used thread count, worker, and in this function pointers are being added. So this is a constructor where thread is created and put into that here. Hardware concurrency. If the thread number of threads create and start thread here. And okay, let's execute this and see the result. This is pretty complex. Thread pool. So all of the threads are created and exited. We have thread ID access, create thread pool with 4 worker thread. We saw that. And this is the place, thread pool. The object was created and it was here, and then it is each thread executes the thread worker thread function, and then submitted 10 tasks. We have thread created, thread started, and then here thread ID, task submitted, task submitted, and that is task submitted is here, main. Where is it? This is a submit. So we saw the submit and task submitted queue. There are a couple of tasks here, and place is adding to that task vector. I think it was vector queue, and first is 1, 2, 3 tasks are there, and picked up task, the thread, this particular one will, let's see, thread, started, started here, thread started, thread, worker thread started, and we saw that picked up by, we saw task submitted, picked up by, and tasks submitted. There are 10 tasks we had, and so there are some tasks picked up, so the count is again set to 1, 2, 3, 4, 5, 6. Picked up task here. This is that worker thread, and task here, task move from the front, and pop, it will remove from the task itself, and picked up task. Now new size is reduced to 1 after picking up, and it executes that way, and we have all tasks submitted, full status, all tasks submitted, and it is in the main, all tasks submitted. Worker thread pool has those things, thread count, Thread count is 4, queue size is 6, and active task count is 4. Waiting for the task to complete here, and once those thread exits, the threads shutting down thread pool, they're independently running and shutting down, completed task 3 and 5 in duration, the time also. Each task has different duration. Starting task this 6, 8, starting task 10, and complete a task shutting down. And shutting down, the last one, shutting down completed. And we have all tasks have completed the results. And we are printing the results, taking from that results in a vector, and the results are this. And what do you want to see? Thread pool shutdown complete. So we have thread pool shutdown complete. Here is that thread pool shutdown. So shutdown was called here in the destructor of thread pool, and that's it. Shutdown is complete, and the results are printed in the main. Yeah, we will have to go through that again, and or maybe go back and forward and to see the results and see the code. And the code will be there in GitHub. So this is very interesting concept that we have parallel processing going on, synchronization going on, and a task, multiple tasks are taken by the thread, and the threads are taking the task, executing, and removing from that place. And it's a thread pool. That's what the thread pool is. And one more thing I want to see, where is that? Is here. Worker thread on the top. Oh, that's not the place. This is thread ID. Completed task. Picked up task. And okay, so this is complex. We need more understanding about thread in order to use this thread and C++ and the function pointer and the new concept like future, std function, and synchronization, lock, mutex, condition variable, and atomic. So all these are used in synchronization in order to get the task done by multiple thread pool. Okay. And we will dive into even advanced concept of C++ and look at that, generate some code and see and try to learn. And with that, I will see you in the next lesson. And thank you.